Now we're at the bottom of page 5 for the 7.6 notes and another application problem. This one's number 18 from page 464. So we're going to read, breathe, read it again, and then apply our problem solving skills. The formula, n equals t squared minus t, the whole thing over 2, describes the number of football games n that must be played in a league with t teams if each team is to play every other team once. Use this information to solve exercises 80 through 81, and we're doing 80. If a league has 36 games scheduled, how many teams belong to the league, assuming that each team plays every other team once? So we've read it. Deep cleansing breath. Let's read this again. See if it'll make sense the second time around. The formula, n equals t squared minus t over 2. Anytime they give you a formula, you can just do a little happy dance because you don't have to translate. They're giving you something. More than likely, we're going to be plugging something into that formula. Describes the number of football games n that must be played in a league with t teams if each team is to play every other team once. Use this information to solve number 80. If a league has 36 games scheduled, how many teams belong to the league, assuming that each team plays every other team once? So let's just put down what they've given here. We've got a goal here. Let's see what that is. How many teams belong to the league? So the goal is to figure out how many teams. And they told us that T represents teams. So we're not going to stop till we figure out what T equals. Okay? And let's figure out what else we've got. They've given us this formula. Love it when they give us formulas. N equals T squared minus T over 2. And now we know that T equals teams because that's our goal to figure out. But what does N equal? Well, N is the number of football games. So N is the number of games that are played. And in part 80, it says the league has 36 games scheduled. So we're going to replace N with 36, because that's what's given, and then we're going to be able to solve for T. Well, it sort of reminds us of a quadratic because we have this t squared piece here, but we've got a fraction involved too. So let's go ahead and we can utilize one of two things. One is we can just start doing the steps, which would be to rearrange this till it's standard form, which means everything has to be on one side, which would force you to multiply both sides by 2 and get rid of the fraction. Or you could think, okay, I've almost got a proportion here. I've got a fraction equal to a fraction. If you consider that 36 is the same as 36 over 1, I could cross multiply here. And 1 times t squared minus t is just t squared minus t. And 2 times 36 is 72. So you could rewrite this as 72 is equal to t squared minus t. However you want to do that. Thinking about as getting to standard form, starting that process, or setting it up as a proportion and multiplying. If that was confusing to you, how I got that, make sure you ask for help because that's a Math 60 topic and I'd be happy to go over that with you until it felt solid. If you had the instinct of multiplying both sides by 2, great, that'll get you to the same spot, 72 equals t squared minus t. But now we need it in standard form, everything on one side. I'm going to go ahead and just move the 72 this time because it keeps the t squared positive, and that's going to be really helpful. So I subtract 72 from both sides, and I get 0 equals t squared minus t minus 72. Okay, that the 0 is on the left, not a problem. It means the same thing. A little bit of time lapse here as we get our factoring done. I get 0 equals t minus 9 and t plus 8. And then we're going to set each of those. I'm running into my space here. Sorry about that. T minus 9 equals 0. T plus 8 equals 0. That's the zero product property. Solve that. You get t equals positive 9 and t equals negative 8. Now here comes that fancy word that I said in the last segment. These are both correct algebraic solutions. You could try these in both equations and they would work just fine. However, because of the situation, sometimes in a story problem where you have real life examples or data, you will get correct algebraic solutions, but they don't make sense in the story because t equals teams. You can't have negative 8 teams. So this is what we would call an extraneous solution. There's a cool vocab word for you. An extraneous solution, meaning it is a solution algebraically, it works, but it doesn't make sense in the situation. So it doesn't make sense in the story, even though it's correct algebraically. So we're going to toss that. Okay? So the only solution that fits our story is the fact that t equals 9. So how many teams are there? There's going to be 9 teams. All right, and take a moment to kind of talk through what you've seen here on both of these, and then try one of these application problems for yourself, number 84. This would be a great time to pause the video, try this one on your own. There's a lot going on with this problem. Don't just skip over it. Really try to work it through. This will stretch your brain. It will let you know how much you're absorbing and if you would be ready to face an exam problem like this. So pause the video. We'll come back for the answer in just a little bit. Okay, so when we come back for this answer, you should get that the base is equal to 8 inches, and the height, because it asks for both the base and the height in your final answer, should equal 15 inches. Okay, now this is one that I would love to do with you in class if it didn't make sense to you, or you got a different answer, or you got stuck kind of in the middle. You had a lot going on. You had to bring something to the problem. This was a BYOF, bring your own formula, because they had to do with area of a triangle. This one involved fractions because the area of a triangle is 1/2 times base times height. So you had to know how to deal with, what do I do with fractions now in the middle of all this? It had some pretty good heavy factoring involved. And then it also ended up with this new concept of an extraneous solution. So I'd love to go over this one if you have any questions about it. Otherwise, we'll just see you in class. That marks the end of Chapter 7.